Hello, I'm going to discuss my solution to the LeetCode problem search a 2D matrix. It's today's problem in the October LeetCoding challenge. I've been solving all these daily challenge problems and there is a video of each of them in our playlist, October LeetCoding challenge solutions. Take a look. It's in our YouTube channel, GoMaster Coding Interviews. Please do subscribe to it. Right. So the problem definition is as follows. So we have a 2D matrix of order m cross n. That means m rows and n columns. And the matrix is sorted in a way. Every row is sorted in ascending order from left to right. And the first element of every row is greater than the last element of the previous row. Right. So what does this translate to is, if you flatten this matrix in row measure order, like the way we see in this particular order, it's a sorted array. And we need to find the target in that, right? So there is an element in that, we are searching for it. So it should be a typical binary search problem. But we don't have a single dimensional arrays, we have two dimensional array. We can actually convert this into a single dimensional array in this way, right? It's a row measure order. But actually we don't need to convert it. We can always, on the fly compute the indices, right? So treat the whole matrix as a single dimensional array starting from, 0 here, and then if there are m rows and n columns, it's going to be mn minus 1, right? So let me write that here. So 0 is the first element, and then mn minus 1 is going to be the last element in that single dimensional sorted array, right? But yeah, how do we so when we're treating this as a single dimensional array, but we need to access the element from the matrix, right? So if we are accessing, say, kth element here, right? Or maybe you can think of, normally in binary search we need the mid element, right? So this is the index of the mid element, right? So mid is the index of the middle element. So what is this mid index translates to I comma j? So I is going to be, because yeah, if you translate it, I think you already know this idea. So it's going to be mid divided by number of columns, which is n in this case, and floor of that. So if you do integer division, it is as good as floor, right? So that is going to be the ith row, and jth column in that is going to be the offset within that, which is going to be the mod value. So mid mod n is going to be the jth index. So that's why you can treat this as a single dimensional sorted array, and whenever we want to access the element from the array, you you basically compute I comma j of that particular index what we want to access, and then access it from the matrix, right? So that is more like an interface to us, right? So let's use this idea, and we already know the binary search method here. There was another daily challenge few days back, and there is a video of that one. Please take a look into that. We are going to use the same binary search idea. So m is the number of rows. If number of rows is 0, so there is nothing to search. So we're going to return false. And n is the number of columns. And but as usual in binary search, I'm going to find point to low here at 0, and high is going to be mn. So the whole matrix is actually, m cross n. So there are mn elements. So 0 is the first element, and then mn minus 1 is the last element. High is pointing to 1 beyond that. Why? Because in this binary search, I'm trying to find the target here, but if target is not found, then I'm gonna point to an element which is the smallest element, which is greater than the target, right? So that's what we're gonna find. So we don't this while loop is not going to return anything else. It only returns low. Low is going to point to either target. If target is not present, it's going to point to the smallest element, which is greater than the target. So if the target is greater than the last element, it's going to be mn, right? That's why we are going to start with that mn. It is part of the possible values, possible answers. All right. So otherwise binary search, I don't think I have to go again and here, but one thing I want to make sure here is, so look at this one, the way we are accessing the mid element in the sorted array. So because everywhere we are treating this as a sorted array of one dimension, but mid is that index. So I'm converting that mid to I comma j, as we discussed already. So I is going to be mid divided by 2, integer division there. So it's floor, and mid mod n is going to be the offset within the row, which is j, right, or the column index. So that's how we're going to access that element, and as usual there is binary search applied here, right? But when we come out of this one, low is going to point to target if it is there, but if it is not there, it's going to point to the smallest element which is greater than that. But how do I know it is pointing to the target actually? So first necessary condition is low has to be lesser than mn, because if it is mn, obviously we don't have that element, right? And even if it is less than mn, that element, that whatever low is pointing to, which is I'm using the same kind of conversions here. So the element which is pointed by low should be equal to target. If it is that, then we are going to say the element is present. Otherwise, it is not present. So we're going to return false. All right. So let's submit this and see whether it works. Yes, it has accepted, and it should run pretty fast. Look at this. It's binary search on a sorted array of size mn. So it should work in big of log of mn, right? So this is the time complexity of this, and space we don't need extra, so it is big of 1 extra space, right? So this is the tight bound for this problem. That means asymptotically there cannot be a better solution than this. All right. So yeah, so let me know if there are any other ways of solving this, or if you have any questions or comments, please comment below. Otherwise, yeah, please like the video and subscribe to the channel. Thanks for watching.